All right, hi everyone. Welcome back to this section 4.4 video. And in this video, we're going to solve an initial value problem, given some initial conditions, y pi equals 0 and y prime of pi equals 2. So these are our initial conditions. And we're going to solve this initial value problem using the method of undetermined coefficients. So when we have these non-homogeneous equations, we want to identify the homogeneous and non-homogeneous components. So this y prime plus y is our homogeneous component, and that gives us our complementary solution. And this 4x plus 10 sine x is our non-homogeneous component, and that's where we get our particular solution from. So we want to use undetermined coefficients. Okay, so we want to use the method of undetermined coefficients to solve this initial value problem. So when we do that, always the first thing we do is get our complementary, because our general solution is our complementary plus our particular. So step one, let's get our complementary solution. So here we'll say solution and step one. And step one is solve the complementary solution, y sub c, using the auxiliary equation. And that's from section 4.3. Okay, so in order to do that, we need to identify our homogeneous differential equation. And so this would be y double prime plus y and just equals 0, getting rid of that non-homogeneous component. And just remember that the standard form for these constant coefficient differential equations is ay double prime plus by prime plus cy equals 0. A, B, and C are constant coefficients. And so here, looks like we're missing a prime. So this would be A equals 1. B would equal 0 because there's no y prime here. And C would just equal 1. And so our characteristic equation would be m squared plus 1 equals 0. And so we want to solve for m to get our roots. So this would be m squared equals -1. And then if we square root both sides, we get m equals square root of -1. Well, that's just I. I guess you could say plus or minus I, but we just get I. Okay. And we have a complex root now. Okay. Remember the form for a complex root. It's, alpha plus or minus beta I. So here, alpha is 0. There's no alpha term. And beta would just be that 1 attached to the I. And just remember that the solution for complex roots is e to the alpha x times c1 cosine of beta x plus c2 sine of beta x. Okay, so if we create this complementary solution now, this would be e to the 0x times c1 cosine of 1x plus C2 sine of 1x. Well, e to the 0x just becomes e to the 0, which just becomes 1. So my complementary solution is just going to be C1 cosine of x plus C2 sine of x. Okay, so that's my complementary solution. So that's my complementary. It's always the easiest part to do because now we're going to get into trying to find out what my trial particular solution is and solving for the coefficient. So here we'll say step 2, uh, form trial particular solution. Okay, so here my non-homogeneous part from the differential equation is 4x plus 10 sine of x. So 4x plus 10 sine x. Okay, so a trial particular solution would be ax plus b for that 4x and put parentheses around it. And then we have a sine, so we need to account for sine and cosine. So what we'll say here is plus d cosine of x plus, excuse me, we'll say plus c. Well, let's use d. Sometimes the c gets confused with the parentheses, so we'll say d. I like that better. Plus e sine of x, that's our second component. So we have d cosine, e sine. Well, wait a minute, that looks familiar to our complementary solution. We already have a constant times cosine and a constant times sine. So this right here would be a glitch. So we'll say glitch. We already have C1 cosine x and C2 sine of x in our complementary solution. So our new trial particular solution would be just tacking on an x to our sine and cosine. So redoing our trial would be ax plus b plus dx cosine of x plus ex sine of x. And that is a good particular solution. Okay, so we need to get the derivative and the second derivative. So why don't we pause the video, go ahead and see if you can get the first derivative and the second derivative, and then double check in a second. So pause the video and give it a shot. All right, welcome back, everybody. So hopefully you gave this problem a shot and found that when you're doing it, you need to use the product rule a lot for these derivatives. But hopefully you gave it a shot and you came to the same conclusion I did. And if not, pause the video and correct the mistakes. But this is what we get for our particular solution and the first and second derivative, okay? This fourth line here, I just simplified it, but this is what we're going to be using for substitution into our differential equation. So we're going to move on to step 3 and, plug in. Step 3, plug in the particular, its derivatives, first and second into the differential equation and solve for A, B, D, and E. Remember, we didn't use C because the parentheses are a bit confusing, especially with cosine. There's too many C-looking items going around. So we just use instead of C, and then we just use E. But okay, let's substitute in these particulars. So let's go ahead and substitute in. We get negative dx cosine x minus 2d sine of x minus ex sine of x plus 2e cosine of x. And that's all. I'm going to put some brackets instead of parentheses. Yeah, that's all the first term. You know what? Let me backtrack a bit. Let me put the differential equation for reference. Okay, so it's y double prime plus y equals 4x plus 10 sine of x. Just for reference, so we plug in our second derivative, and there's no y prime, so we're just gonna plug in our particular. So this would be plus y, which is ax plus b plus dx cosine of x plus ex sine of x. And this all equals the right-hand side, 4x plus 10 sine of x. Okay, so this is my setup. So there's nothing really to distribute in. So maybe what we could do is perhaps drop the brackets and just start simplifying here. So what cancels out? Well, I have a negative dx cosine x and a positive dx cosine x. So those cancel out. And I have a negative x sine x and a positive ex sine x, and those cancel out. So what I'm left with is negative 2d sine of x plus 2e cosine of x plus ax plus b equals 4x plus 10 sine of x. Okay, so that works out nicely. And so we're going to now use our standard process of rearranging terms to equate coefficients. So we want this left-hand side to look the same format as the right-hand side. So the way I would rearrange this is I would have ax plus b plus 2, or I would do sine first because we have a sine over there, minus 2d sine of x plus 2e cosine of x equals 4x. And we need a placeholder for that constant plus 0 plus 10 sine x plus 0 cosine x. Okay, so let's go ahead and and equate these coefficients now. All right, so our first equate would be AX equals that 4X on the right-hand side, and that just means A equals 4. Okay, pretty straightforward. Let's now look at our second equation. B would match up with that 0 constant on the right-hand side. So that'd be just B equals 0. Great. Let's move now to our third equation. This is where we're dealing with the sign. So this would be 2 minus negative 2D sine of X equals 10 sine of X. So we equate those coefficients. So negative 2D equals 10. So that means D equals negative 5. Okay, and we move on to our last equation. This would be 2E cosine of X equals 0 cosine of X. And so that equate the coefficients, 2E equals 0. So that just means E equals 0. Okay, so we got all of our constants. Let's go ahead and plug them into our particular solution. So step 4, plug A, B, D, and E into our particular solution. Okay, so our particular solution was what? It was AX plus B plus dx cosine of X plus EX sine of X. So our particular solution would be 4X plus 0 minus 5X cosine of X plus 0X sine of X. And the 0 terms go away. And we're just left with a particular solution of 4X minus 5X cosine of X. Okay, so we have our particular solution. Let's finish writing up our general solution and then deal with the initial value problem. But, step 5 is always the general solution. Y equals the complementary plus the particular. So our general solution here is C1 cosine of X plus C2 sine of X plus 4X minus 5X cosine of X. And that's our general solution. Okay, so we have an initial conditions to worry about. Remember, this is an initial value problem. And I have some initial conditions we need to use to figure out what C1 and C2 would be. So we're going to use these initial conditions and figure out the rest of this problem. So coming back down. So for the initial value problem, we're going to first use the original function. So y of pi equals 0. So this means that we would have 0 equals C1 cosine of pi plus C2 sine of pi plus 4 times pi minus 5 times pi cosine of pi. All right, so sine of pi goes to 0. Okay, and so what I'm left with, or, or cosine of pi goes to -1. Cosine of pi goes to -1. And so what I'm left with is negative C1 plus 4 pi plus 5 pi. And so I'm going to move the C1 over to the left-hand side. And so I get C1 equals 9 pi. And so I get my C1. I'm just going to plug this back into the general solution. So y equals 9 pi, using my general solution from up here, 9 pi cosine of x plus C2 sine of x plus 4x minus 5x cosine of x. Okay, so now we got to use our other initial condition, y prime of pi again equals 2. So we need to use the derivative. So I need to take a derivative of our general solution. So this would be uh, derivative of 9 pi cosine would be negative 9 pi sine of x plus C2 cosine of x plus 4, and then it would be a product rule for this 5x cosine x, and that would end up being plus 5x sine of x minus 5 cosine of x. So we'll say product rule. Okay, so that's our derivative. We need this derivative to plug in our initial condition. So what this becomes is 2 equals negative 9 pi sine of pi plus C2 cosine of pi plus 4 plus 5 times pi sine of pi minus 5 cosine of pi. Okay, let's see. The sine pi's cancel out. They all go to 0. Cosine of pi is -1. Okay, so what I'm left with is negative C2 plus 4 plus 5. So I get 2 equals negative C2 plus 9. And I end up with C2 equals 7. Okay, so I got my constants. So my initial value problem solution is 9 pi cosine of x plus 7 sine of x plus 4x minus 5x cosine of x. And that's my general solution. Okay, So, quite a long problem. We took care of business normally by getting our general solution, and then the initial value problem is the different component where we need to plug in the original point, like y pi equals 0, and then also need to take a derivative to plug in our second condition. But we get C1, C2, and that's our solution. Okay, so that's it for this video. Thank you for watching, and I'll see you in the next one. Take care.